Hi, welcome to the video on challenges in implementing k-means. By the end of this video, you will be able to identify and overcome implementation challenges in k-means. Now in the previous video, we understood the basics of k-means algorithm. Now before we move on to implement k-means algorithm, let's look at the challenges we might face during its implementation. One of the common challenges you may face is that the sizes of clusters are different. Let's say you have points like this. If you look here, the left and rightmost clusters are of smaller size, whereas the central cluster has a bigger size. Now if you apply k-means on these points, the results will be something like as shown on the right hand side. If you look, we have 3 clusters here and the shapes of the clusters have been changed. This is the challenge with k-means, as the output result, that is graph on the right side, is poor as compared to the expected result, that is the graph on the left of the screen. Another challenge with k-means is when the densities of original points are different. Let's say these are the original points. Here, points in the red cluster are spread, whereas the points in the remaining clusters are closely packed. Now, if we apply k-means on these points, we will get clusters as shown on the right side of the screen. So the compact points have been assigned to a single cluster, whereas the points that are spread loosely but were in the same cluster have been assigned to different clusters. Again, the graphs on the left and on the right of the screen are quite dissimilar. Hence, k-means also face difficulties while dealing with points of different densities. These are some of the difficulties or challenges which may be faced while working with k-means. So what would be the solution of these challenges? One of the solutions is to use more clusters. We used 3 clusters earlier in the examples and saw the results were not appropriate. Let's see how the results will be when we increase this number to, let's say, 10. So here we have used 10 clusters and we can see that the clusters now make more sense. So when the size of clusters is different, we can use more clusters. Here we have 10 clusters, but let's say the final requirement is only 3 clusters. In such cases, we can merge the closest clusters until we get the required number of clusters. This is how we can overcome some of the challenges faced while using the k-means algorithm, as the clusters which have abnormally low inter-cluster distances will be merged. This works as a workaround for the clusters of different size or density. Using this technique, the right graph will eventually turn into the left graph. Now, the question arises, what should be the optimum number of clusters to have? Should we use 3 clusters? Should we go for 10 clusters? So, is there a way to get the optimum number of clusters? To understand this, let's take the customer segmentation example which we saw earlier. Here, the bank wants to segment its customers based on their income and amount of debt. Now, here we can have 2 clusters which will separate the customers, as you can see here. Here, all the customers with low income are in one cluster, whereas the customers with high income are in the second cluster. We can also have 4 clusters as shown. Here, one cluster might represent customers who have low income and low debt. Another cluster is where customers have high income and high debt, and so on. There can be 8 clusters as well. We can have any number of clusters. Can you guess what would be the maximum number of clusters? Theoretically, we can assign each point to a separate cluster, and hence in this case the number of clusters will be equal to the number of points or observations. So the maximum possible number of clusters will be equal to the number of observations in the dataset. In our customer segmentation example, we can visualize and say that having 4 clusters divides our dataset into more meaningful clusters. But here we only use 2 features, which are income and amount of debt, and hence it was easy for us to visualize and decide the right number of clusters. But what if we have multiple features? In real life scenarios, we can have hundreds or even thousands of features. Visualizing all those features and then deciding the number of clusters will not be possible. So, how can we choose the right number of clusters? Well, we will find the answer to this question in the next video. See you there.